Today I am going to talk about magnetism. In 5th century BC, the Greeks already knew that there are some rocks that attracts beads of iron and iron nails towards itself. They are very plentiful in the district of Magnesia. That where the name magnet and magnetism comes from. This rock contains iron oxide, iron oxide, which we call magnetite. In 1100 AD, Chinese used magnetite needle to build compasses. In 13th century, it was discovered that there are two places in magnetite needle where maximum attraction occurs. That I am just showing by this putting around. They are called poles. They are called poles. If I denote this pole by A, this by B, then by observations A repel A, that is shown by the outward arrow, B repel B, that is again shown by the outward arrow, while A attracts B and B attracts A. This inward arrow shows that they attract to each other. There is a huge difference between electricity and magnetism. In electricity, you can have two polarities, that is denoted by plus and minus, that is the charges, while you don't have that choice in magnetism. In magnets you cannot have isolated poles, right? Suppose this is a magnet, this is a rectangular magnet, so I call this magnet as a bar magnet, right? Suppose this is a point A or pole A and pole B. If I break this magnet into two and further, you just see that broken portion here, right? This will remain A while this is going to become B now, while this is another broken portion where B is remaining B and this is going to become A. So you are not going to get monopole in magnets, right? They does not have isolated poles. Magnets comes in pairs, that is poles are going to be in pairs. They always have dipole. However small you make this magnet by breaking it, still you are going to see that they are going to have a dipole, A and B. While in electricity you can have isolated charge, then you can see this charge as a monopole, right? Positive monopole. Same way, if you isolate negative one, then you are going to see the negative monopole. You can even have a dipole if you have two charges of different polarity but of equal strength placed near each other with the distance r, separating distances r, then they are called as dipole. They are called as dipole. In 16th century, the scientist named William Gilbert discovered that, right, Earth itself is a giant magnet. I'm drawing that earth with the green shade. This earth itself is a giant magnet. He is experimenting with magnetite compass, and he is the person who has mapped out the magnetic field lines from the earth's surface very effectively. If you take one of such magnetite needle, right, and you see that this side of magnetite needle points towards the northern Canada, that is situated towards the north pole of earth, that is geometric north pole of earth, while other portion is towards the south pole of earth. These are called as the geographical poles of earth, right? That is, I am by using convention writing here north, this pole I am writing north, right, while the opposite one I am writing south pole, and I am just shading that portion. But as you know that A repels A, B repels B, right, A attracts B, and that's the reason that magnetic south is going to be situated in the geographic north of earth, while the magnetic north is going to be situated towards the geographic south of the earth. The magnetic needle here shows you north and south direction that are geographical directions, that is north pole and south pole, that is north pole and south pole. So this is the way we define the direction of north and south of magnetite needle.